Hello everyone, good afternoon. My name is Hange and I'm from Department of Engineering at King's College London, and I'm very happy to share my work here today, which is about coupling food preservation with energy system for enhancing efficiency and sustainability in African informal market. So food is a very important source for keep people alive, like everyone needs to eat. And And Africa is the home for 1.4 billion people, but unfortunately, like 65% of them fall to ill every year because of eating those contaminated food. And meat has been found as one of the major contributors for those illness, together with the crops contamination and inadequate cooking, inadequate freezing, and inappropriate storage temperature are the main causes for those soiled meat. And large percent of them are found already contaminated before it is bought. And informal markets are very unique and widespread shopping locations in Africa. Data shows that 80% of food consumed in Africa is sold in those informal markets because they are always like very cheap and accessible. And refrigeration is one of the common ways to maintain the food quality, but these markets are still like having those facilities missing. And different from the conventional meat value chain showing up here, like animals in Africa, after they are raised up, they will directly enter the livestock and therefore to enter the informal markets. And this is the typical composition of the meat informal markets in Africa. Like they will have a livestock holding area, an abattoir, and retailing sections, which means that meat vendors, they will keep animals in the market, and they will also like do the slaughtering jobs in the market as well. And the sliced meat will just stay on the shelf under the high ambient temperature, like maybe for a couple of hours or even like the whole day or maybe like a couple of days until someone finally purchases it. And here are some challenges that we have concluded that may hinder the development for those efficient cooling facilities. Well, we think that it is a mistake to think that we can just simply adopt the solutions from more developed countries, like with favors that large commercial operations over the smaller producers. So, for example, the refrigeration process is always energy intensive, but most of the countries in Africa, they're still facing the electricity unstable. So the power outage can last still like for several days, like without any like lights. So and also most of the meat vendors, they do the business in those informal markets, they will have the unstable incomes. So they show relatively lower affordability to invest in those efficient cooling facilities in the ones. So here comes to our research question, like how to develop an affordable, scalable, and sustainable cold chain for food in highly constrained area with no or limited electricity access. And are there any key interdependencies between the food and energy systems since energy is very relative to the food system? And here's our approach. We started with a field trip so that we can actually engage with the local marketers and to gain the insights from them to see like how they think about the cooling food. And we want to define the connections between the energy and food system. And we'd like to propose a consumer-centered approach for market-based energy planning solutions. And finally, we will extend it to a national network. So last year, during August, we had this chance to visit Nigeria, which is one of the most populous countries in Africa. And the city Abuja we went is the federal capacity territory of the country. And there were 5 different meat and mixed grocery markets we visited. there are more than 50 meat vendors we have the chance to talk with. And there are some takeaways from the trip. So based on observation, it's a unique market conversation I have also mentioned during the background. They have the multi-functional informal market, like they do the different stages of the meat value chain in one market. And also the frequent power cuts, like all 5 markets we went, they are experiencing different levels of power outage. They don't have lights, like can be like up for like 3 or 5 days. And the vendors, they need to buy the ice blocks to keep the lower ambient temperature for the meat to keep it like keep it cool and fresh. And they will place the ice block around the meat so it can create a relatively cooler temperature for the meat. And relatively wealthier market, the vendors, they will buy the diesel together to generate the diesel generator. Obviously, it is not a sustainable solution, and especially the machines they're using are always like quite old, like showing up with this picture. So it also further reduces efficiency as well. And based on the conversation with the meat vendors, we found out the connections between the markets. So basically, one relatively bigger market, it will supply the neighbor smaller markets. They will do the slaughter in one bigger market, and they will supply the sliced meat to the other market. And almost all the vendors, they showed interest to those cooling facilities, but they still express that they don't really want to pay too much for those facilities, even though they know that they will have the payback in the longer term. So there are some like inspiration from the field trip. So we normally address the issue from the perspective of the energy. We think about how to use energy for the food system, how to manage the energy like better to create maybe a better cold chain for the food. But this will obviously cost a lot of like resource and money because we obviously need to expand the infrastructure and we want to stabilize the connection. So why not to think from the food itself? Like we need electricity to produce the cold energy, and the cold energy will preserve the food. Like for example, we put the food in the fridge cabin, and this is the cooling environments that we will help to lower the food temperature and maintain the quality. But the electricity itself cannot really preserve the food. So the cold energy is the main part. So in our study, we propose that we think the refrigeration unit itself as the cold energy storage and release center. So when one market is equipped with the maybe off-grid refrigeration units, it's the refrigerated meat will be able to transport to the neighbor markets when needed. So it will become a code embodied meat transmission line, just like the electricity transmission line tries the electricity, but this meat transmission line will be able to transfer both meat and food energy. So this is possible to think of it because like the food informal market is everywhere in African like countries, including Nigeria. So because of its high accessibility, so if we see each informal market as a cold energy hub, it is possible to address the issue of unreliable electricity. So we can just transport the cold embodied meat instead of to expand the electricity infrastructure and the electricity. So here is the configuration of our model setup. Here is the single market simulation, and we use HATSA for the modeling, which is an open energy modeling tool for the simulating and optimizing the electrical power system. And in the HATSA, we created the electricity box. It will connect with the PV generator and battery storage. And we also create another code bus that will connect with the code demand. And in our case, the code demand is the code energy required for preserving the meat. And we also added bridge as a link between two buses. So this will be doing the energy transforming, like from electricity to the code. And after building up the one market configuration, we can extend it to the two market. Therefore, we can simulate the code transmission lines. And here's the battery performance. You can see that when there is no code transfer enabled, like both markets will be needing the separate refrigeration system with the battery. And in this chart is shown by blue and orange line. And when the code transfer is enabled, the battery performance has dropped to 0, but the battery performance at market 1 has been largely increased and showing here by the green line. And this chart shows the bridge performance and the code transfer performance. And it's very similar to the battery performance. Like when there is no code transfer enabled, it's where the bridge separately in two market, it would be like working separately. And when the code transfer is enabled, the bridge performance at market 2 has dropped to 0, but instead the bridge at market 1 has been largely increased. So this indicates that the code energy for the transmission line balance the cooling demand, which is shown by the dashed purple line here in the middle. And this will largely reduce the burden of the bridge at market 2. And we did the cost analysis as well. So the total cost of the system has been largely reduced because of the elimination of the PV panels and the bridge at market 2, even though the market 1's PV panel and bridge capacity need to be increased. So here's the conclusion. We introduced a new perspective on sustainable development of food energy system, and we emphasize the effective management of energy demand for food preservation. And we also verify the feasibility of food and energy system coupling. And our simple model has also showed that the cost is possible to be reduced at least 22%. So for the future direction, because at this stage we are still focusing on verify our hypothesis framework. So in the future, the data of course need to be more further verified and justified. And also regarding the food, it's the only meat we are considering at the moment. So it is very necessary to include more ranges of food, for example, the vegetable and fruits and fish. And we will also, the next step is to scale it up to, as I mentioned earlier, like to a national wide framework. So that's it. That's all I want to talk about. Please let me know if you have any questions.
Thank you very much. Questions?
Okay, good job. I have a suggestion. I suggest you, for this, you should maybe focus on the meat market for those who buy, develop, and then sell.
Yeah.
I'm saying this because as Nigerians, I'm not Nigerian, I am Kenyan. Yes, and our lives are similar. Yes. When you hand over the refrigerator to us, we won't use it for the meat, we use it for something else. We won't use it for preserving the meat. We will use the energy for something else. We only direct the energy to what we need now. In the rural areas, for example, we don't use refrigeration. We use something we call we even use sunlight to dry the meat.
Yeah, but that is one kind of like dried meat and another like product.
Yes. So for refrigeration, I think it will work for those who buy in bulk as wholesale, then we walk to the wholesale to also buy for consumption. Yes, but if you generalize it for the country as individuals and households in India.
Yeah, so our focus is not for the public, it's mainly for the market. So, just that, like, it's for the making for the market, in this case study. But so if we want to introduce this refrigeration in meat market, so I think they would use it for the meat.
No, okay.
It's not for like for you to use it at home. Is that what you would say?
My point is, some we even prefer our be at the markets rather than you kill the animal and have it.
Mm-hmm. Well, would be so. No, I think the vendors they kill the meat like at once, like not like when customer come to the retailer station, like customer they will not wait.
Yes.
They buy the meat from the shelf, and all the vendors they kill the animal like maybe in the morning or maybe like the day before. So the meat at that stage it needs somewhere to store.
Mhm.
So this is where like they put the meat there. So this can like increase the vendors working efficiency and also increase the meat's freshness.
For experience, fish produce or fish products
Yeah.
applicable to your research. But for animal meat, from my experience, it doesn't work.
Okay.
Maybe as an initial question or recommendation to this, you
Yeah.
mentioned that you did a field trip. I think it would be super important to reflect sort of your ideas that you're having with the people, the local communities where you're trying to apply this. Because in fact, when it's related to the participatory modeling that we introduced earlier, and in fact, when we talked to, in our case, it also became clear, and again, this is for the households, that the last priority that they had for electricity was for refrigerating, but they looked at irrigation for agriculture, for example, as a topic that they wanted to use the electricity. So I think that would be a great approach of actually going into the local communities and reflecting your ideas with the needs and having the local stakeholders integrate. So my first idea was that maybe like the community aspect could also feed in there, saying rather than refrigerating, having people join together, and then when the meat is actually available, that it's distributed about different families or something like this. So I think going into the community and reflecting your idea would be super important.
Yeah, so this is what we did during the field trip to Nigeria. So we had this chance to talk to the meat vendors from Nigeria. So maybe the conversation here is maybe we should like explore Africa to visit like more other countries and to hear out like more people's voice. Cause yeah, thank you for your advice.
All right, further questions? Yeah.
So, how are you considering studying on disability items for the